Hi, welcome to the unit on radicals and rational exponents. This is lesson 3, simplifying radicals. Okay, you've learned how to simplify a square root, but now we're going to look at how to simplify a cube root, fourth roots, fifth roots even. So I'm going to show you how this works. Okay, let's start with some simple ones. Okay, we're going to find the cube root of 16. Okay, we want to write that as a radical. So what we've got to do is we actually have to do a factor tree for 16. So I'm going to take 16, I'm going to break it down to prime factors. So 4 and 4, and I got to keep going to 2 times 2, and then 2 times 2. So I have 2 times 2 times 2 times 2 is equal to 16. Now I'm taking the cube root of 16. So instead of finding pairs like I did in square roots, I have to find groups of 3 because we need to find what 3 things multiply together to give us 16. And we don't have a perfect root, so we're going to simplify this by finding groups of 3s. Okay, we know 2 times 2 times 2 is equal to 8, and 8 is a perfect cube. So we're going to simplify that portion of it and then leave this portion in under the radical because it doesn't have a group to slide out with. So you find groups of 3. So when you find a group of 3, you're going to circle it, and then, as I say in my story, 2 of them get killed on the way out of the radical. So I have a 2 that escapes out of the radical, and I have the cube root of 2 left because he didn't have an escape partner. Okay, so the answer is 2 cube roots of 2. Okay, so let's look at that for the fourth root this time of 81. So let's take 81 and break it down. 9 times 9, and then 3 times 3 times 3 times 3. Okay, this time I'm looking for groups of 4 because it's a fourth root. And notice I have 1, 2, 3. I have 4 3s. So there's my group of 4. Okay, now what happens is I don't have anything left. So my radical is gone. I no longer have it. But I take these and I kill off 3 and I take 1 3 out. And so my answer is just simply 3 because I had one group of 4 3s. Okay, let's try a couple more of those so you can start practicing with me. Okay, well let's look at some and throw a few variables in there because variables seem hard, but they're really not. Okay, so let's take the cube root of 24, x to the 4th, y to the 9th. Okay, so let's look at that one. Okay, 24 is not a perfect cube, but let's try to find some factors. I'll take 2 and 12, and then 12 is 6 and 2, and then 6 is 2 and 3. Okay, so what are the prime factors? Let's see. I have this 2 times 2 times 3 times 2. I do have a group of 3, don't I? Okay, well let's go ahead and just take the variables next. X to the 4th means I have x times x times x times x. I have 4 of them. And y to the 9th, wow, that's a big one, isn't it? It means I have 9 y's. 1, 2, 3, 4, 6, 7, 8, 9. Okay, so 9 y's. Let's try to find our groups of 3s though, because we are taking a cube root. So let's see, I've got my 2's here. I'll take a group of 2's out. So I have a 2 coming out. Okay, oops, I've written that too far over here. Let's write it up here. So 2, and then my 3 didn't have any way to get out, so I'm going to leave the 3 under the radical. Okay, then my x's. I have 1, 2, 3, 4. I have to find a group of 3. So an x gets out, but I have an x left. Okay, and then my y's. I had 9 of them. So let's do groups of 4's. 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 groups of y's. So I'm going to bring a y squared out because I have 2 groups, so that's y squared. And I still have 1 left, and it's y. So there you go. That's how you simplify cube roots that aren't perfect. You take out groups. Whatever group of 3 you have, you take one of those out, and whatever doesn't have a way out stays in. If you have more than one coefficient in, like if you had a 2 and a 5, or a 3 and a 5, you would actually just multiply them back together on the inside. Okay? And then you just write your exponents, or your variables that are left, And both of these had a first degree because I had one x left and one y left, so that was x and y. If you had two of those, you would write it as x squared. Okay, so there you go. That's how you simplify those. The only other, I guess, thing I need to show you is what do you do when you're dividing, okay? What if you have 2x and you've got something fancy like, I'll just go back to a square root for a second. Let's say we've got the square root of 20, x to the 5th, y to the 4th, over 25x y. Okay, so we've got a coefficient in the front, and then we've got some fractions, all kinds of stuff. Well, first of all, let's see, what do you notice? 25 is a perfect square. So let's go ahead and take it out of the radical, okay? So I'm going to take that out as a 5. Now, this x and that 5, or x to the 5th, cancel out, because remember I can cancel these. And I'm going to take that x out, and that's going to be x to the 4th. And there's a y, and it cancels with one of those y's, so I can cancel that y, and I can make that a cube, okay? So that means my whole denominator is now cleaned up. My 5 came out, my x canceled with that one, and my y canceled with that one. Okay, so I still have a 2 on the outside, an 2x on the outside. I now have a 5 on the outside. My radical is only left on top. So let's bring down 20x to the 4th y cubed and see what we can do to clean this one up a little bit, okay? Let me write this a little closer because that's just a coefficient. Okay, 20. I'm going to go make a side note over here. And 20 is 10 times 2, or 5 times 2 times 2. Okay, there's my pair. So I'm going to bring a 2 out. Well, I already have a 2 there, so I have to take 2 times 2, and I get 4. Okay, so what's my coefficient that's left? 5. Okay, let's take my x's. I have x to the 4th. Well, that's x times x times x times x. I'm finding groups of 2's because this is a square root. I have 2 groups of 2's, so that's x squared. Okay, and then I have y, and I have y times y times y. Okay, my groups, I have one group of 2, so I have a y come out, but I have a y left. So there we go. Okay, all that is in the numerator, and then I have this 5 to bring over in the denominator. Can I simplify my outsides? Nope. So there we go. There's our final